Good morning, and welcome to this session on SAS SQL methods and more. If you're new, or even if you're experienced, there's an opportunity to become more proficient in using SAS SQL to do queries. So let's get started. The first chapter, and there are 4 chapters, just a brief introduction, and give you an overview of what we're going to do in the logistics. Chapter 2, we will focus on performance considerations. We'll talk about computer resources used when you submit a SAS program, and how can you benchmark. Chapter 3, we will look at doing explicit queries against data sources like a relational database, such as Oracle or Teradata DB2. We will use a live name statement to do what we call implicit pass-through. That means it will look at your request, and if it can pass your query to the database, it will. If not, SAS will handle it. There are some data set options that we can use with implicit pass-through, meaning direct pass-through, and also explicit pass-through in SQL and proc SQL and proc fed SQL. So if you understand the SQL associated with that database, you can write it and send queries directly and have the database handle it. Chapter 4, the concluding chapters on queries, perplexing performance problems. And we'll talk about subqueries, correlated subqueries, when they're useful and when they're not useful. The last topic, cross-library options. And then in chapter 5, there's learning more, just some tips on what you can do to go from here. What SAS offers in terms of support and different user groups, for example, user groups, professional services, technical support, education, publications, and you can get plenty of information through support.sas.com on training and these other topics. So I'm going to stop sharing, and then we are now going to kick it into chapter 1, and we'll stop at the end of each chapter and oftentimes have a workshop. Chapter 1 will focus on an overview of the course, what we will do, and the logistics to help us gain insight on SQL. So as an overview, here are the objectives. We will talk about the topics for this course. We will talk about SAS Access, which is really the software behind the scenes that allow you to access data in different sources like relational databases and PC products. We will talk about the methods for accessing relational data. And to get you set up for the virtual lab, there are a few steps I need you to follow to prepare for use of SAS and SAS Access within class. About this class, we focus on a number of things, including correlated subqueries. We'll talk about the performance of an SQL query. We'll do SQL pass-through directly to the database and write it in such a way that the database can understand it and handle your request. We will focus on cross-library options, understand their implications performance-wise, SAS options to help us evaluate the submission of your code and what happens behind the scenes. So there's some options to help you do what's called a benchmark, where we can look at things like how much memory was used, input-output operations, how much CPU time it took for your tasks to run, and so on. This will help us identify and eliminate some things that are not performing well if possible. So what do you get with the SAS Access software? I want to talk about that. If you're retrieving data from a SAS data set, many of you have done this in the past, the data set, proc steps like proc reg, proc freq, to go against SAS data sets and return results as a report for a table. Now, here's a little note. With appropriate credentials, you will be able to write to vendor database. In other words, the administrator for that data source, if they give you permission to edit or create tables, you will have some. Be able to do so. If not, if you don't have read access, then that's all you'll be able to do. Just use those tables and not change them. So what do you get with SAS Access? You get the interface engine like Teradata Engine or Oracle. You have the ability to do SQL pass-through code native to that database. Plus, you can use the live name statement to access tables in the database. The interface engine, well, there's one for each major data source or database, like Teradata, that's a Teradata engine. For Oracle, what you get is an Oracle engine. And that will permit you to use SQL procedure, either proc SQL or proc fed SQL against a database. You can select columns and rows from a table, or you can do non-query statements as long as you've been permitted to do so, like granting access to certain tables to a population. The live name statement uses the engine to treat the database tables as if they were SAS datasets, and you can use them in procs and datasets. Behind the scenes, the engine will generate database-specific SQL for the data you're retrieving from using the engine or on behalf of the engine. There are many options we can take advantage of, and we'll see those as we go along. So what do you get with the Oracle engine? You have the ability to go against the Oracle client, to make requests, go to the Oracle server, and pull tables from that database. In the Windows machine, in this class, we will have everything on one box. We'll have the SAS products, the SAS Access to Oracle, and we'll have the Oracle Save server in the Oracle database also on that same machine. We're running on a single machine in this class. But typically, you would have more than one machine. So that's it for the overview. The main key things is that we'll use proc SQL, proc fed SQL to do retrievals against relational databases like an Oracle database. So what about the course logistics? What do you have to be aware of to get the most out of this course? There are 3 editors, which many of you are familiar with, or you're probably more familiar with the one that you typically use. We'll talk about the files you need to bring in. And also, prepare you for the virtual lab environment. That will be the final one of the key steps. So in this course, you will write SQL programs to, number 1, go against SAS datasets. We call the data Orion star data. Plus, you will retrieve some tables from Oracle. The 3 interfaces at the bottom, you can see we have the Enterprise Guide, Studio, or the windowing environment. The windowing environment has been around the longest and is accessible on the Windows, Linux, Unix, and IBM mainframes. The Enterprise Guide interface is only available in Windows environment. And notice the first bullet, point and click. So what does that mean? That means there are tasks from this task pull down for processing your data. Data management, like doing SQL join. Yeah, I could write SQL, sort. There are tasks for data management and reporting and analytics. But in this course, we will write our own code with the full programming interface. Studio is very similar to Enterprise Guide, but it's more of a web-based HTML client. And it also offers point-and-click tasks as well as a programming interface, which you can use in this class. So you have to pick which one that you are more comfortable with. Actually not. If there's one you want to try, you have the opportunity to do so in this course. As we go along throughout today, I will ask you to bring in different programs. One is called SQL 01, for example, the 01. SQL is SQL methods. That's what the acronym is implying. And we will give you a chapter plus a letter. One of these letters, like activity, demo, exercise, solution, we'll put that in there and then some item number. Next hour, you should be fine. No problem at all. There's SAS help and online documentation. There's information on relational databases you can see online. The SQL procedure in more detail. Fed SQL language as well. And database product users guide. And SAS access to a particular database like Oracle. Let's take a look at Chapter 2. All right, Chapter 2, the topic is performance considerations. And so what we will do here is look at computer resources that's required behind the scenes and what you can do efficiency-wise. To decipher how certain resources are being used, we can do some benchmarking, and I will show you how to do that. So let's focus on computer resources and efficiency. So what are the resources that are you really use? Let's take a look behind the scenes. I want to talk about those resources related to SAS program efficiency. I will show you how to do a benchmark on resource usage, and look specifically at those options we have to activate to get reporting statistics on those resources. So when you submit a SAS program, there are resources behind the scenes that are really displayed on the screen that are being utilized in many cases. The CPU time, the I/O, memory, data storage, network bandwidth. Those are some of the things that are considered resources for the computer network. Programming time is really dependent on your skill level. So that's not included in the SAS program resources. The CPU time. That stands for the amount of time that it takes your central processing unit to perform a program, process a program, and handle operating system tasks behind the scenes. So that includes things like calculations, reading and writing data from a data set to a data set, conditional logic like if then else, select wins, iterative logic, do loops, functions, character, numeric, statistical, and then all of these things are measured in seconds. I/O, that stands for input output. Input, reading of data. O for output, outputting data. So generally you pull data in from a storage device, do some processing, and either typically create new data and store it. That's your output. Input from storage to memory and output from memory to storage or display. Memory is the size of the work area, and we call it in volatile memory because this doesn't always use the same amount for executable program modules, the data that's loaded, and the buffers that are used behind the scenes. The memory is required for those different items. Data storage is the physical space that's needed to store your data on storage devices such as disk drives, tape drives, flash drives, memory cards. The next resource, network bandwidth, the available throughput. That's the capacity for the computer network to move data from one point across the computer network to another point. The greater throughput allows more large amounts of data to be moved. So these resources, CPU time, I/O, memory, these are resources that the programmer can manage with SAS programs more efficiently. There's some things you could do. The programming time, I would say no, because again, the programming time is not considered a computer resource. It's dependent on your skill level. You have a novice SAS programmer versus someone with extensive experience. If you give them a complex program to create, of course, that novice user will generally take more time. All right, so what I wanted to point out, I ask you to do, I will give you a minute. These definitions, I want you to match with the resources to the right. So indicate the letter that applies to the description of the resource. The physical space needed to store data, that's data storage. The amount of time used for calculations, iterative logic, conditional logic like select wins, if then else, and reading and writing of data, that's CPU time. Size of the work area for holding executable program modules, the data and the buffers, that will be considered memory. Measurement of read and write operations, input output, that's I/O. And lastly, throughput for data communications right across network bandwidth. Here we go. So once again, what happens? You submit a SAS program. The computer's executing a SAS program. Well, the software needs to be loaded into memory. You do a proc and a variant. Software has to be loaded into memory. The program needs to be compiled. Make sure you didn't have any syntax issues. Then it will execute that compiled program. And if you're creating a report, it returns a report. If you're creating one or more tables, it will store those output table or tables. Generally speaking, when you minimize one resource, try to reduce it, you typically increase another resource. I want to give you some examples. Now, one of the factors in the performance of utilization of these resources would be your table sizes, your data source sizes, and the type of data sources you have, like SAS data sets versus Excel spreadsheets or relational database tables. They all make a difference. Let's say that we're trying to reduce the capacity to store a data set, the amount of storage it requires. We have this large table with millions of records. You can compress it. Compressing might reduce the size, let's say by 40 to 50%. However, when you use that compressed data set, SAS has to uncompress it, and that takes extra time. So that means you are boosting up the CPU time required to process that data. Again, oftentimes reducing one resource increases another. So you have to decide what's most important for you. Let's look at another example. Let's say that you're trying to reduce the I/O, the number of operations it takes to bring in data and write out data. You're trying to reduce those operations. Well, one of the things you can do is increase your buffer size. The buffer is a unit of transfer between storage and memory. So if you increase the ability to bring in the buffer size, you have the ability to bring in bigger chunks of data. That will reduce the number of times it takes to load all your data in or write all your data out. But as a consequence, that means you're taking up more memory on your computer. Reduction in I/O typically increases the amount of memory you're using because it requires more capacity to house your data coming in. So you have to decide what's most important for you. Is it more important for you to reduce data storage, reduce your I/O, reduce your CPU time? You have to decide that fact. But the things that are part of this equation would be, again, your tables, the sizes, the type of tables, data sources you're using, your computer environment, how often you run your programs. Is it every day, every other day, or just a one deal? You're going to run this one program just for the day and not continue it going forward. Are you processing a small amount of data or a large amount of data? Here's a multiple choice question for you. If you decrease the disk space usage, for example, compressing, which resource might increase in usage? CPU time, I/O, both, or neither? Our answer, I/O. A compressed data set, for example, requires less storage space, but it will require more CPU time to uncompress that data set when you're using it. You have to understand, you need to understand your site's technical environment, such as hardware you're using, your SAS environment, the operating system you're using, system load, those things can come into play. They all affect the processing. You need to understand your site's hardware. Are you running on a solo computer or are you running on a network being shared by people? Memory, how many CPUs you have, communication hardware, the network bandwidth, storage, all of these things factor in. The number of users or jobs, you all sharing a server, for example, maybe more jobs run at night or maybe just before lunch. Understanding your site's operating system, the resource allocation, job scheduling, I/O capability, the installed SAS products you have, the number of CPUs for SAS programs that are being used, the memory for the SAS programs, the methods for running SAS programs. Some of you are familiar with perhaps batch mode submission, non-interactive submission versus interactive submissions. When you're using an interface, you submit code and get your responses right away versus running a job at night. Above all, you need to know your data. If you don't, there are ways to investigate. Some of you have probably used proc contents. You can also use some of these interfaces to look at the metadata or properties of some of these data sources, but not only data sets, external files, relational databases like Teradata or Oracle, DB2, SQL Server, PC products like Microsoft Access, Excel, OLAP cubes, if you've used those before, I currently use those, information maps, so on. The data can make a difference, small, medium, large. The length of your program can factor in the complexity, the size of your data sources, I mentioned that, and how often you run that program. Is this a one-shot deal and you got a medium data set, or are you planning to process a huge table? Do you have a production job that runs maybe 3 times a week or every night? Those are some of the things you need to think about if it's worthwhile investigating, trying to improve the efficiency. To improve in efficiency, on which of the following should you focus? A, programs that read large data sets. B, small programs. C, programs that read small amounts of data. D, programs that run often. I would say definitely D, because it's like a production job, one that runs often. And then A, if you're dealing with many large data sets, and it may take a while to process them, so you're trying to think strategically the best option to maybe combine the data, for example, merge versus SQL. So here are the two answers. Programs that read large data sets, and D, programs that run often, production jobs. Rules of thumb for relational databases. If you're trying to do a query against relational databases, it's better to let the database do that task. Joins, order by, sorting. Right? If that's the case, I would choose SQL over the data step and merge, because the database itself handle that more efficiently. I/O latencies, by limiting data to retrieval, you can control certain aspects, such as reading only the columns required for operations. Some of you may be familiar with keep equal, drop equal. Use the where instead of the subsetting if. The where is faster than the subsetting if, typically. And keep where expressions as ANSI standard, so that if you apply it against a database table, it will be translated to SQL that the database table can process. And last bullet, avoid correlated subqueries. And we'll talk about those later on. This is just some guidance, rules of thumb. I'm going to transition to benchmarking. So let's say I'm thinking about 3 ways to process these large tables. I'm thinking about maybe using ProcSQL. I'm thinking about using the data step to merge, or maybe using the data step with an index to do a lookup. So I've got some options, but I'm not sure which one is best. We can benchmark. Right? We'll talk about when benchmarking is necessary. We actually have a percent benchmark macro that we will use to compare the efficiency of programs. Maybe we have a couple we're considering, but we want to compare them, right? When your performance is critical and you want to benchmark because this is some task you're going to do a lot, and let's go back to the comparison of ProcSQL versus maybe a data step. Some of the things you might measure or look at in your log would be things like real time, user CPU time, system CPU time, memory, operating system memory. Those are some factors that you can look at. And there is information online in the help facility, the online SAS documentation, that describes these things. Real time is like wall clock time, in instances where there's a waiting period, so we both submit jobs at the same time. It might process part of mine, part of yours, and there's a waiting period. User CPU time would be the amount of time it took SAS to process that step. System CPU time would be the amount of time included for buffers. So if you're running a data set, if they're setting up some buffers behind the scenes, the whole data coming in, data going out, those things. And then memory for the data and your step you're using. Operating system memory would include memory for the things behind the scenes, like some of the buffers used. So benchmarking is trying to measure the resources used for maybe your program, one or more programs. So we're going to use these factors to look at different techniques. We do benchmark. These are some guidelines. So I'm trying to contrast, perhaps, dataset merge versus using proc SQL, or using proc SQL order by versus proc sort, just as examples. So here are the steps you need to follow. Definitely recommend it. Turn on the options before benchmarking that you need to track more performance information. Test each technique at a time. So maybe I'll run SQL by itself and then start a new session and run the dataset merge by itself. Run each program 3 to 5 times and come up with average resource statistics. And test each technique. Again, I'll use the example of SQL versus the dataset merge in separate SAS sessions. And when you're finished, turn off the options that you use to track more information. Also, exclude outliers from your analysis. There are some system options which are operating system dependent. So for example, if you're running in an IBM mainframe, there are options associated with that environment. There's still quite a few mainframes out there. Stats, memory report, full S-timer, S-timer. S-timer is the default. It's already turned on and it tracks real time and CPU time in the SAS log. Full S-timer is available for you to turn on if you want, especially for Windows and Unix. You can get more information. By default, as I said, S-timer is turned on. You can get the real time, CPU time it took for your task to run. Full S-timer breaks it down further. You get real time, user CPU time, and system CPU time. The user CPU time is maybe the amount of time it took that proc SQL step to run. System CPU time includes the amount of time it took to set up some buffers behind the scenes. So you can turn more details on with options full S-timer. The default is no full S-timer. Which of the following, here's a multiple choice, should you not do when you're benchmarking? Let's go through the list. A, execute the code for each technique in a separate SAS session. Oh no, that sounds good to me. B, use an average of resource usage value rather than the minimum. So don't run each technique once and make a decision. I like that one. C, when you benchmark, make sure the system is idle. That doesn't sound really good. D, include only the SAS code that is essential for performing the task that you are measuring. A, B, and D sounds good to me. C is the only one that you should not do. Some key principles, again, in reference to benchmarking. You do it when it's necessary, when you want to compare resources. Is it worthwhile for you to do this analysis and compare utilization statistics on different coding techniques? You've got this code example versus this code example. You're trying to see which one's more efficient. Run multiple iterations of each technique. And remember, we already said this, look at the average results. Average CPU time used, average amount of memory used. Use realistic size data. So if you're comparing two techniques, don't use small tables, use what you would typically use. If you typically use table sizes with 80 million records, test it out that way. And run each iteration in a separate SAS session. Don't run this technique in benchmark and then run the next technique right behind it. It's better to isolate that. Here's a macro program that we've written for you to compare programs that you are considering. So there's several macros, actually. The percent benchmark is the driver macro that we'll call pass info macro. It's a utility macro that makes to make logs for that runs more machine readable, and the percent benchmark sparse that parses performance statistics from your logs to prepare a report. Then the benchmark report, which is a utility macro that produces a final report. So they work sort of in conjunction together. But the percent benchmark is the one you start off with, which calls the other few macro programs. The macros are all in the AutoCall library. If you've heard of the AutoCall library before, the way it works, we have programs with the same name as the macro. For example, benchmark macro, there should be a program called benchmark.sas that creates the macro and pretty much executes it. So this AutoCall library folder is the master custom AutoCall macros folder. If you want documentation, the benchmark macro you can put as a parameter value, exclamation point help. You get some information in the log. Feel free to try this. When you're comparing two programs, it's the same macro, and you put the first program you're comparing, second program. Now, amperpass is a macro variable that we assigned the value of S workshop to earlier. So you could type it in or substitute S workshop to this macro variable. Bottom line is I'm comparing SQM02D02 to SQM02D03.SAS programs. You'll get output, you get summaries of each run. Remember, we're trying to come up with average numbers, so we run it more than once. And here is clock time, CPU time, memory used by each technique. And you'll get a chance to try this in the workshop. So I'm going to start a new share and go to my virtual environment. SQM02D01 in the workshop folder. And try to make this just a little bit bigger so that you can clearly see this. All right. So here's the macro program, and I'm putting the value as exclamation point help, and I'll run this solo. And you can see in the log notes about this macro program. Then I'll run this macro program against the two SAS programs, D02 and D03, to compare them. So I'm not sure you need the content of the code, but let's say it's legitimate code. I'm just comparing two techniques to see which one runs more efficiently. Remember that benchmark macro program calls other macro programs. Right? And it's giving us, looks like an HTML report. We're getting some univariate statistics on things like CPU time. And if you eyeball down towards the bottom, there's notation on outliers excluded from the comparison. You scroll down, just get all the way down to the bottom. There's a benchmark score for the two programs I want you to look at. And it shows you the clock time used by both programs. And then it tracks the CPU time used by both for comparison and how much memory is used by both. Now, these two are pretty close in results, but that oftentimes will not be the case. And then you can see the 5 runs for each program and each clock time, CPU time, memory versus the average numbers. These are some of the tables created that's used to perform the reports. All right, so you will have an opportunity to try this in workshop. Okay, so I'm going to stop here to conclude chapter 2. Thank you. All right, ready to start chapter 3. So let's get started. I'm going to share the first screen, this chapter. We will talk about implicit versus explicit pass-through SQL queries. And basically, what we will do is use the live name statement referencing in Oracle database. And what we'll do is try to specify options with just standard data step, proc step code to encourage the database to handle certain parts of the query, or try to get the database to handle certain parts of the query. So we will also use data set options, and then we'll talk about explicit pass-through. How can we write native SQL code that the database can understand and do some processing on its side to improve performance? And we will use proc SQL, and we will also use proc fed SQL, talking about the differences between the two. So let's get going on setting up the live name statement and talk about implicit pass-through. All right, so we're going to set up a live name statement to set up a library reference like we would for a regular SAS data library, but this time we will point to an Oracle database. We will be able to retrieve Oracle tables and use them as if they're regular SAS data sets, and procedures like proc freq, proc means. We'll use the data step against Oracle tables. Now, if you'd like to verify if the database is handling part of the query, like a where, or maybe performing a function, a summary function, we can use the SAS trace option to help us determine that fact. We can look in the log and look at the notes to see if the database was able to handle it. Here's a live name statement. Again, many of you probably seen this. The library reference is just a word, 8 characters or less, begins with a letter underscore, and then you can put numbers in the mix. The physical location of your data, if it exists, and options. There are a number of options you can use, like the ability to read only, give access to the ability to read so you can't modify the tables, things like that. The SAS access live name statement is setting up a library reference to an Oracle database or a Teradata database. And you reference the tables to level names just like you would with a regular SAS data set. And whatever authority is in place, the access will honor that authority. So if you have access to certain tables, read access, then you will not be able to modify those tables. Here's an example. We have Orion, DB, and then instead of the default engine, we specify Oracle because I want to go to an Oracle database. And then the connection information options like the path, the username, password, schema, which is associated with Oracle. And if the syntax is correct, then in the log, we should see a message similar to this. Live rep Orion DB was successfully assigned as follows. The engine, Oracle, physical name, local host, where it resides. Here are the options: user equal, the Oracle username, the password, the path. Okay, that's an Oracle server name that defines the hosts file or DNS, sorry. And then the schema, which is associated with Oracle. So the SAS Access Engine allows us to use those tables in Oracle database, just like it would in the case of regular SAS data sets. Now, as we do queries in a procedure or even in a data set, it may attempt to try to pass parts of the query to the database to handle. And that's a good thing most of the time, because the database can better do retrieval, wheres, and also use mathematical functions, summary functions, if they are able to be converted to the Oracle version, an equivalent version on the Oracle side. All right, so here's some notes at the bottom, just emphasizing what I said. If operations cannot be converted to the DBMS like Oracle SQL, then SAS will have to handle it. It will bring the data down to SAS to do maybe some filtering or to create some columns or to use functions. That can have an impact on performance because you're bringing down a huge Oracle table because your query did not allow the database to handle it, passing data down to the SAS side to complete the query. All right, let's look at that first example, syntax-wise. I have a proc means and I have a where statement. In the proc means I'm asking for certain statistics, min, mean, max, on total retail, broken down by customer ID. Then we have a filter where year of the order date is 2010. Now the year function will extract the 4-digit year. Now keep in mind, order fact is in the Oracle database. Let's see if the Oracle database can handle this query against that table. If we have the SAS trace option on, we will get notes in the log indicating what happened. And as you can see highlighted in this sort of blue color, it was able to transition this syntax in such a way that the database can handle it. So the Oracle database have an equivalent function that it can use to extract the year from the order date and compare it to 2010. So it was successful. The year function has an equivalent Oracle function. Let's try the weekday function. The reason I have date part, because that extracts the SAS date from a date time column. The date part is the number of days since January 1st, 1960. Most of us know that story. And then we'll use weekday to return the number between 1 and 7. 1 is Sunday, beginning of the week. 7 is Saturday. And if the weekday is 7, I want those records to be processed to analyze total retail by customer ID. So this time in the log, because we have SAS trace on, I haven't showed you the syntax yet, and we will get to that, but there's a warning. The where clause contains SAS-specific syntax that cannot be passed to the database. That's good. I would want to know that because I may be able to change the syntax such that the database can handle it and make it more efficient. This is good to know. These are different functions or capabilities, should say, that the database, the Oracle engine, supports. Functions like count and min, log function, the floor function, seal function, average, standard deviation, upcase function. So the Oracle database can handle these functions, or it has equivalents on its side. So oftentimes, the same result can be produced different ways. But our goal is trying to get the database to do the work for us instead of passing it to the SAS side. In most instances, it will be better for the database to handle, efficiency-wise. All right, especially when you're writing a where, because a where is filtering records coming in. Right? So if you go against a database table, the where is applied, it will control how much data is passed down to SAS. If it cannot handle the where clause, then all of that data comes down to SAS, and SAS will filter it on its side. So let's think about this. I'm selecting supplier name, count. The star is just going to count the records as products from the product dimension Oracle table, and I'm filtering. From this table, product dem, I don't want all of the data. I want to filter only for the records where the supplier name contains the word sports. Now, if you haven't used scan, scans can scan the value of a column from left or right. If you use a non-negative, an absolute value number, it will search from left to right. If you put a negative number, it will search from right to left. Well, all I want to check is the last word in the string. It's the last word sports. So I do a scan of supplier name, -1. Well, how do you know it's retrieving the last word? Because it's looking for a delimiter. There are default delimiters if you do not explicitly specify one, like a space, a period, a comma. Those are default delimiters. But it works. We're checking the last word to see if it's equal to sports. Then we do a group by, because we're doing a count, in order the products in descending order. Well, let's verify if scan was translated to an equivalent function in the database. Well, we get the result. We check the notes, unable to convert the query to a DBMS specific SQL statement due to an error. Okay. Well, it's basically saying it wasn't able to do it. SAS will do the processing. Okay. So we get the supplier name from here, but the where was not applied, which means all of that data from the table has to be passed to SAS. All right, just an idea exchange. How could this where be rewritten to improve the performance of the query? Remember, we have scan, supplier name, getting the first word from right to left, looking for sports. What about the like operator? Some of you have used the like operator. So we will go with like, because it can be translated to an equivalent operator for the database to handle. Where the supplier name is like, if you have not used like before, you can type the text you wanted to search for. It's looking for a pattern. You can use a percent symbol or underscore to indicate characters. Percent symbol means any number of characters. Underscore means any single character. So the way this worked, I'm asking for any characters, a space, and the word sports. So sports is at the end of the string. All these characters precede it. All right, we get the same result. Check the log. All right, prepared. Take a look. Here it is. That was submitted to the Oracle database to process that table where supplier name like percent sports. So it was able to use that function to have the database perform that task. So here's the setup call. Will this where be handled by the database to filter against the artifact Oracle table? If you think about it, I would imagine that most databases would support an equal comparison. So the answer is true. Let's move on to 3.2 and talk about dataset options with implicit pass-through. We will use some of the dataset options and use SAS Access dataset options to regular SAS dataset and options with an Oracle table. Some of you have seen the keep equal or drop equal. You don't use both. You keep what you want or drop what you don't want in terms of columns. It can improve performance at times. You have 397 columns in a table and you only need 5. Why read all of those other columns? You can keep the 5 you want. That can improve efficiency. Let's take a look at the drop equal option. You either drop what you don't want or keep what you want. The asterisk denotes in SQL that I want all of my columns from the product dimension Oracle table. But next to it, I'm using a SAS dataset option. Drop equals supplier, colon. The colon indicates every column that begins with the word supplier. Supplier ID, supplier country. Where the product name like, here's the like operator, and we already confirmed that the like operator can be converted to an equivalent on the database side, right? Or used on the database side. What about drop? Let's see if there are any columns that begin with the word supplier. Down below, the answer is no. So apparently it worked. Instead of the star and then a drop, you can be explicit and tell it which columns you want. You don't put a comma after the last column, but that list requires more typing. This compared to this. You get the same exact result. And there's no guessing. The database will certainly handle this. All right, I'm going to bring in SQM, this program 03A02, and submit it, check the log, and see what effect, if any, the drop equal dataset option produced in the DBMS SQL query. I'm going to transition to my virtual session. A02. And I'll make this just a tad bit bigger so you can see it a little bit better. Notice I'm using the SAS trace option. You finally see it. SAS trace location, put the notes in the log. This option will make the notes more readable. And here's my proc SQL select. All the columns with the like operator. And then in the second select, I use the drop equal. Okay. And then I turn trace off so it doesn't continue to check and give notes in a log. All right, we get 2 reports. Here's the first with the star. Prepared. You can see the select, expanded with all the columns, even the supplier, and the supplier country, those that begin with the word supplier. And check it out, even the where product name like, we already verified like would work by the database. And then in the next one, I'll choose all of the columns but drop supplier. So as you look at this prepare select, it does not include anything supplier. So both work. Both were handled by the database, which is good. That's what we want. Okay. So I'm going to switch back to my slides. What portion of the SQL query submitted to the database was modified by the drop equal option? I think you saw that. It wasn't where, it wasn't from, it was the select, where you select which columns you want. That's the answer. All right, so there are data set options like keep equal, drop equal. Well, SAS Access data set options also exist for the Oracle database, like DB, database condition, rebuff, OR hints. The DB condition would allow you to specify an SQL clause that's processed by the database. Rebuff will control how many rows to read into the buffer. That can potentially decrease network activity if you are reading in bigger chunks of data at a time. Right? Remember, when you improve one resource, it typically goes against a different one. So you think about it, if you're pulling in more data, you might be taking up more memory. And then there's OR hints that influences the decision made by Oracle, the Oracle optimizer, rather to have the database process part of the query, all of the query. Can be used to improve efficiency. Let's go back to the weekday story against date part. And here are the notes. Cannot be passed to the database. We saw this earlier. Even though it cannot translate weekday, there are some specific DBMS SQL, if you know it, if you understand it, that you can specify to improve the processing. All right, so we'll use some dataset options to improve the performance of a proc means, okay, on the SAS platform, and then replicate the proc means for the database to do that task, explicitly passing it to the database. Let's try these options. The DB condition allows you to pass database specific, like Oracle specific, where clause for filtering. Right, so give it a shot. Oh, also notice you put it in quotation marks. So here it is. Next to the order fact Oracle table, I put DB condition equals, and in quotation marks is basically what I want. Where to care order date D equals 7. Basically, I'm looking for the day of the week, 7, which is Saturday. Uh, this is more specific to the Oracle database syntax, not the SAS syntax. So if you understand this, you can type it yourself. If you know the ANSI standard for Oracle and its extra features, if you're familiar with it, go for it. That's what DB condition will allow you to do. All right. So it says Oracle prepared. Select these columns where to care order date D equals 1. That minimizes the movement of the data from the database table down to SAS. DB condition. As I mentioned earlier, this option you can use to control the amount of data coming in. How many rows in the buffer? You can increase it or decrease it. Might result in more memory usage. Here it is. Perhaps you could speed things up by increasing that read buff number. This particular change made almost no difference when I put in read buff equals 1,000. If I made it higher, it might make a difference. With it, without it, look at the statistics, the clock time, which includes any waiting period, the CPU time, okay, to actually perform the task. They're very close, and how much memory was used. There's not a big distinction in terms of performance between them. But sometimes minimizing the I/O can improve performance. Let's look at this option, this dataset option, or OR hints, the Oracle hint text. Okay. So this might provide hints to the Oracle optimizer to make a better decision and speed the processing. So let's try this option. Okay. We put OR hints, and here's the DB condition. Highly parallel tables, full table scan, if you call this, retrieve data. All right. So let's look at the speed boost. We went from without it, and look at your real time, 0.48, user CPU time, system CPU time, and look at the drop with the hints. All right. So it pays, that's the note at the bottom, to know the specifics of that database. If you are comfortable and you've been writing SQL for Oracle or Teradata and you know that syntax, go for it. You can use it in this option to improve the likelihood of it performing your task. So what are the advantages and disadvantages of an implicit SQL pass-through, where there's a decision made between SAS and Oracle as to who will handle? Well, first of all, it provides transparent access to the database tables. The data and proc step syntax looks as you've always used it. If you have knowledge of the database, in this case, Oracle SQL, it's not necessary because it will try to translate things for you. Some SAS functions like min, max will automatically translate to the database. Remember that you had year and we had weekday. Year work, the year function, it was translated, but not weekday. And remember scan, the issue with scan, right? What are some of the disadvantages? If you reference the Oracle tables in the data step and you're using merge, then it will not be passed to the Oracle database to do a join. A subsetting if will always be done by SAS. Okay? There's certain options, if you're familiar with them, that you can try to use to improve the likelihood of the database processing, especially when you're pulling down a lot of data. You have large database tables. So the idea, if you can get the database to do some of that processing on this side, that will speed things up. All right, 3.3. We go from implicit to Explicit with Proc SQL and Proc Fed SQL. So here are the objectives. We'll take a look at Proc SQL and Proc Fed SQL, look at some of the advantages and challenges of both. We'll do explicit pass-through through both to the database, and then do a review at the end of both. So what is Proc SQL? Structured query language. It's been around a long time. Back in the 70s, that's when it was developed to go against relational databases. So there's history associated with it here. So the latest version is based on ANSI SQL 2 1992 standard. There are some standards most vendors follow, like using a select, using a from, using a where. Can use it against any SAS data set. Includes many SAS extensions, like dataset options, SAS functions you can use with Proc SQL. You can use case logic for like true or false. Can process double and char data types. And you can do explicit pass-through. Check out the syntax. You can connect to the database. That's required. And then you issue your typical ANSI standard or version of SQL for that database. If it has enhancements, you can use them. If it has beyond the ANSI standard, you can use whatever the capability is. In this case, we have a select, columns 1, 2 through n. You put the syntax as from connection to DBMS, we're referring here. And then in parentheses, you can indicate your specific database SQL query. You can also execute other DBMS specific statements by that database. And when you're done, disconnect. That's a pass-through. You're passing your query directly to the database. So the syntax has to be correct. It has to be acceptable, but you still will get an error. Let's go back to the story. Once again, weekday. When we receive the message, it cannot be passed. All right, remember that? So how can we improve this? We could use dataset options to improve the retrieval in proc means, or we can rewrite proc means in the form of Proc SQL and do an explicit pass-through. Remember we did this earlier. We went against the Oracle table, order fact, rebuff 1,000 records buffer time, the database condition, and where to be passed to the database. And this is how you type it for looking for Saturday, but you have to know the syntax. And or hence to improve the likelihood of it performing that task. That's one option. Here's the other option. We connect to the Oracle database, put in our credentials, then we select start. Now, before we finish that, go below. You see in blue, this color, this aqua green type of color, from this open parentheses to that closed parentheses, we select, we do a query against the database, put a customer ID, we're getting statistics like the count, min, average, max, these arguments assigned to these respective variables from this table, filtering for Saturday, we group by customer ID, and we order by customer ID. So this result set, when it comes back, pass to this select, and select all the columns from that result set. And by default, we get a report, and then we disconnect. All right, more on weekday in the where revisit. Now, if you take a look at this select, this pass-through has both a SAS portion and database portion. It is possible to leverage both. So if you look at the select, we're using a format Z with leading zeros. Okay. We're specifying NOVs, min, the mean, the max, with labels and formats. So code outside of parentheses executes in SAS. We are enhancing that result set. We can do that. These are labels. This report is nicely formatted because of the enhancements. Check out the select, customer ID, counts, then average as those column names from artifact. Here's the result. So sometimes you try to reduce data retrieval, SAS computes the results faster, maybe. Best thing to do, as we said all along, is to benchmark. So I'm comparing the means.SAS program versus SQL to get the same summaries. And we look at our results for the benchmark MapWork program, nice utility program, against the means.SAS and SQL.SAS. You look at the clock time, you look at the CPU time, and the maximum amount of memory. Right? So that's why it's important to still benchmark, as opposed to going by your gut feeling. If this is a program you plan to run routinely, like it's a production job, it's something you run almost every day, every other day, and this will be long-term, not just for a short period, it's worthwhile to put the time in to evaluate the performance. All right, so with ProcSQL, you can query SAS data sets, you can query relational databases doing pass-through code native to that database. But what about Fed SQL? Well, it's new and modern, highly scalable. It's part of base SAS like ProcSQL. It is base SAS implementation of structured query language. Okay, based on the 1999 standard, ANSI standard, you can process data sets to the library reference, very ANSI compliant. So the guidelines you use for ANSI standards select where from. There are few SAS extensions. Most queries from Fed SQL will be executed entirely in the database. Keywords are reserved, all keywords are reserved words. You can do ANSI type logic that results in true, false, or no. Once again, we turn on the SAS trace option. You begin with word options. Notes to the log, make it more readable. And we're plugging in the full S-timer option. Remember we talked about this earlier in the course? It gives you more performance statistics in the log about your step. And in this case, that SQL. Let's take a closer look. I want to select the customer ID, the count, and I'm creating a column called number of obs. Here's the comma, the minimum, the average, the max total retail price as these respective columns. From order fact, which is an Oracle table, here's weekday again, looking for 7, and group in order by. Then return trace off. And no full S-timer to turn off, full S-timer from tracking performance. Despite engaging the SAS trace, we don't have an indication that the database did anything. Both procedures, SQL and Fed SQL, both support undocumented procedure invocation option _method. You can look up this more information in this link. It's _method option. So if you invoke that option, you will get more information. _method, we do the same task against this Oracle table, and we get information about aggregation and sorting performed by SAS. Now, if you want to guarantee the query against your tables will be handled by the database, you can do an explicit pass-through to guarantee that. All right, so let's take a look. Similar syntax to ProcSQL to some extent. Now, you don't see a connection, that we saw with ProcSQL. If you look at the slide here, you can see it points out that it makes a connection and disconnect is not required because it's using metadata from the library to make the connection. You can do an explicit pass-through. You can also execute DBMS specific things like granting read permission to a table. So here's proc SQL. We put the underscore method here so we'll get more information about the method used to do the retrieval. I want to look at what's in the inner parentheses first, because once again, this is what's going to the database against that table. I want the customer ID to count these statistics from order fact, look on Saturday, group in order by. Whatever you get from this will be a result set. That result set, from that, we're selecting all the columns from that connection to OrionDB. So this live ref, since it's pointing to an Oracle database, that determines the platform where this will be executed. And again, you have to type native syntax for that database in these parentheses. All right, so use the method output. You can see in the notes in the log, methods. Task was performed by the database and processed more quickly. So what are some advantages of SQL versus Fed SQL for explicit SQL pass-through? The database can optimize the summarization and filtering, ordering, and joining. It can optimize the use of functions. SAS and DBMS features can be used. SAS features that can be translated. You can run DBMS store procedures and macros. If you have authority, you can execute a drop, a grant. You can drop a table. You can grant authority to read a table. What are some disadvantages of explicit SQL pass-through? The pass-through facility requires DBMS-specific knowledge. You have to know what you're typing. Only SQL code within parentheses is passed to the database. Well, that gives you a result set. Right? So as long as you understand how to write it, you know, it can help you efficiency-wise. Welcome back. We are in chapter 4. The objectives of chapter 4. First thing is correlated subqueries. Secondly, we will talk about cross-library options. The idea of cross-library options is in reference to combining data sources on different platforms or different types, like relational database versus a PC product. And correlated subqueries are queries that cannot work by themselves. So let's take a look at both. So I want to explain how a correlated subquery works and talk about the implications of using a correlated subquery, and then talk about some alternatives to using correlated subqueries. They cannot be evaluated independently, and what that means is that when you try to do a select using that type of query, it doesn't return the result on its own. The way it works, you have an outer query, and you have the correlated subquery. The outer query must work in order for the correlated subquery to work. Let's talk about that. Here's a case study. Let's say that I want a report listing the customer and product identification numbers for products ordered by German suppliers, where supplier country equals DE, as an example. Now, we were actually looking at France, but I'm just giving you an idea. So here's some things to consider. You have 3 tables. You have a product dimension table with product information, such as the product name and the product ID, who the supplier is, well, the supplier for that particular product ID, the supplier country. And the order fact, the big order fact table, we have order information along with the product ID of the product that was ordered. In addition, we have the customer ID that identifies the customer that placed the order. And more demographic information about the customer is in customer den. More information about the products is in product den. All right, so there's some things we want from some of these tables. We want the customer ID and we want the product ID from the big order fact table for the orders where the supplier is in France instead of Germany. So we write it as follows. We put where the literal FR is equal to whatever we get from this query. Now, what defines this as a correlated subquery, because it's sort of related to the outer query in such that this query cannot work by itself. Let's take a closer look. I want the supplier country from the product dimension table. That's fine, it's in there. But I only want the supplier country where the ID for each record in the big order fact table is found in a product dimension table, and the supplier country return is equal to France. Now, this query within the parentheses cannot work by itself. And the reason is the product ID for the big order fact table is not on the from clause. It's not in product dimension. So it cannot work by itself. However, what happens is that each record from the big order fact table, its ID is searched for in the product dimension table. And when it's found, the supplier country return, if it's equal to France, then we'll select the customer ID and product ID from the result set. Wow, looks like this took quite a bit of time because it's an inefficient way to do this lookup. This is how it works. Because this query cannot work by itself, this subquery, this correlated subquery, what happens is each record from big order fact is selected, and this inner query looks for its ID in product data. So for example, let's look for 9.5. It's in here, but it has US. Finds a match, returns US, and US is not France. So that's a false, no output. Let's look at the next one. 5.16, we look for it, there's a match, but once again, what it returns for supplier country is not France. False, no output. Finally, once again, because this query cannot work by itself, it reads the next sequential record from big order fact 010, and as you can see, it's here. First one that has FR finds a match. FR's value for the supplier country is equal to this value, and now we can output the customer ID and the product ID. That's how it works. So you can imagine the bigger the order fact is, the more time this will consume. Not necessarily efficient. It processes every row in the outer query, meaning for the big order fact. So here's a quiz. Take a close look. What is the maximum number of rows that will be selected in this outer query? How many records in the order fact, big order fact, will be selected from this inner query when we look for its ID compared to the ID in product? 2, 10, and 6.2. Those are the only two that match that have France. So this is the result set. Those are the matches that were found that have FR, but we only selected the customer ID and product ID from the result set. It's got to be a better way. Because if you have almost 1 million records, let's say 951,669, each one of these records in the big order fact will be read sequentially and looked up in this correlated subquery that's related to the outer query. That's why we call it correlated, because this cannot run independent. It will work once for every row in the Orion big order fact. not too efficient. I can do this with an inner join. I can do this with also a non-correlated subquery. So if you have a better option that's more efficient, go for it. In this example, the correlated subqueries query is very inefficient. The result set, out of the 951,000, there's only 24, 28 that match. Large to small. Two better options in this particular case, the inner join and the non-correlated subquery. Let's take a look at each. Here's the inner join. It's real simple. Remember, I want the customer ID, the product ID from the big order fact table and the Orion product dimension table, where the product IDs are equal, and it's a simple filter for France for the supplier country. Piece of cake. Look at the difference in CPU time and real time compared to these numbers. Nice savings. Another alternative is to do a non-correlated subquery, because this one can run independent. Let's think about what we're doing in this non-correlated subquery. I want a list of the product IDs from product dimension where the supplier country is France. So build a list of all the product IDs for France, for the supplier country of France. Then in the outer query, I will read each record from the big order fact and check to see if this ID is in that list. So once again, we see the savings. So where is a correlated subquery used? Well, in this particular example, if you're trying to update a table and a join is no good here, a non-correlated subquery is no good, well, we're running a correlated subquery this time to update a table. There's an update clause that you could use, statement against a table. So we have price list and we have price updates. Price updates contains the transactional data that have update information, new information. So I want to get the new prices from price updates. So for each record from price list, I'm going to set the price equal to what I get from the result set here. I'm selecting the new price from price updates, where the product ID, price updates, is equal to the product ID from price list. So this is a correlated query, subquery, because it depends on values come from here to do the lookup, to make a change, where the product ID is in, look at this subquery, select the IDs, product IDs from my SAS price updates. So this constructs with the correlated subquery the ability to update this table. There are other techniques. I mean, this works. Time is pretty good. There's an update statement. You've seen perhaps set, merge. There's also update, where we can take the original data and update it with a transactional table, either adding new values or replacing. So how does it know what to replace? It's based on your buy state, product ID. So these tables have to be sorted. Now, what if the variable in updates is called new price? Well, in order to apply the update to price within price list, we have to rename from new price to price. Then we can keep the other variables we want, or restrict what we want. 0.01 seconds. It's faster than this. So some of the key points. A correlated subquery cannot work by itself. Now, it's good for some things like updates and maybe a few other things, but oftentimes it requires additional CPU and memory, because you may be reading the outer table in the outer query. For each record in the outer query, you look for a match from the subquery, which is a correlated query. So that's time consuming. Think about some of the options we considered, like doing an inner join or using a non-correlated subquery. So that's pretty much the summary of this. Correlated subqueries are good in some instances, for example, updates. But if you're using it for other lookup techniques, the inner join or the non-correlated subquery might be more efficient. The last section of this chapter is cross-library operations. The idea here is using data sources from different platforms or different types, I should say. We will look at 3 techniques for dealing with this situation to mitigate cross-library options. So we'll define what it means. To give an example, a business analyst has an Excel workbook and it has a list of customer identification numbers for which we would like demographic information. Plus, there's big customer dimension table in Oracle that has information we need. So these two need to be combined. When you're pulling data from SAS Live Reps across multiple platforms, or from the same platform with different credentials, this is considered a cross-library option. If you have one or more tables that are large, this can be time-consuming across the network. If you're moving data down to SAS, the bigger data you have, the more inefficient this can be. Let's take a look. Look at the blue section I'm highlighting. I have the big customer dimension table in Oracle, or it could be a SAS data set. And I have an Excel spreadsheet. But in this case, remember we were talking about trying to have the database perform well. So this is actually a database table. And we can see the time it uses. But what happens, this cross-library reference with a database management system table plus a PC product, that's a cross-library reference. It works. Time looks pretty decent. If you check the log, the data from both tables were moved to the SAS platform to process the join. Basically, what Oracle did was just control which columns were retrieved in rows. An alternative for this cross-library operation is to take that Excel spreadsheet data, put it in the Oracle database, that's the table, then join those 2 Oracle tables so the database can better handle the result set. But you need read and write access. The administrator, if she or he has provided you with those credentials or those capabilities, then you can create a table in Oracle from the spreadsheet. In the virtual lab, if you use that, the MyLive is assigned to a student schema in the Oracle database, and that student has read and write access, which means she or he can create an Oracle table from the Excel spreadsheet like this. We're going to drop the table in case we created it before and we added more customers to the list. I want to just recreate it. Create table, MyLive, database, select customers as follows, columns from the spreadsheet. So now I have 2 Oracle tables. Select customers in big data dimension. Right? So I'm creating the table I really want. Customer info as follows, the name, customer name, country, customer type ID, birthday, from Orion Big Customers Dimension, and that newly created Oracle table, select customers. Now the database can do the join, can do that inner join, and do it on the database side instead of passing all that data across the network down to SAS. Much more efficient. You can see the select, look in your log, and look at the engine note. SQL statement was passed to the database for fetching the data. That's a good sign in most instances. If we benchmark, we can see there is a drop in CPU time. The clock time is a little bit more here, a little bit more memory used, but there's a drop in the CPU time. Always good to benchmark and follow some of the guidelines we talked about in the early part of this course. You can use this benchmark macro. If you don't have write permission to the database, well, what could you do? Well, we can do what we're calling a pseudo join. And what we essentially do is take that smaller table or spreadsheet, build a format with it, and allow SAS to do a format lookup. So for the codes, we can look up the descriptions we really want, or the labels we want. You need the following. You need a format name. You need a start value to be looked up. You need a label, will be the value to be returned for the start value. And the HLO indicates that the start value is a keyword high, low, or other instead of an actual value. So here's the creation of this table we need to build a format. Remember what I said, you need format name, start label, and we're going to make this one for the high, low, and other values. Here we go. Create a table, call it control, call it whatever you want. And we need a format name. I'm going to call it fake merge. It's like a pseudo merge. I'm going to put the ID number in 16 positions as a string, and it's stored in start. That's the value to be looked up. And then I'm going to assign a label, take me, for all of these customer IDs. That's the label value. That's what will be returned. But what if it's missing? I have quote blank quote that indicates missing as HLO. So what am I going to give it an HLO? Well, that's the conclusion. I build that table, but I insert one more. Insert into control. The insert clause or statement will insert records. And there are different ways you can supply the records. I indicate positionally which columns will get the values, these four. Format name, start label, HLO. And here's the values clause to indicate fake merge goes to format name. Same thing we did. Oops, we did, go back. We did here. And then the start value will be other, anything not specified, meaning those customer IDs. And then not me. HLO will be O for other. That's not the end of it. You create the table, and now that you have the format name, the start, the label, you inserted an additional record. We can use Control-N to point to that table and get the format created. And I'm using what's called FMT Live to give me a report. So I can see for these customer IDs, what label gets returned. Other keyword gets not me, exclamation. Just to give you an idea of something you can do as a possible option. So it's kind of like a pseudo lookup join. We're using a format instead of a table. We select the columns from the Oracle database, customer dem, where the put of the customer ID based on the format equals take me. So any of these IDs will be equal to take me, exclamation. The generated SQL code is pretty strange, but it works. If I compare the two options, the pseudo approach, I save a little bit more time, CPU-wise. So I like the option so far that loads that smaller table into Oracle, the Excel spreadsheet, and do a join by the database. The pseudo join is good if you don't have a lot of values. Another option is to use DBQ, database key, right? And what you do is basically specify which key column you want to use to perform a lookup in the Oracle database or database table, and that might improve performance. So for each record in a small table, look up a match in a bigger table. Database key, either a singular column, a plural, multiple ones. And it takes the value from the smaller data set, one record at a time, build an internal where clause, and executes a series of selects to go find the match. This can be pretty good. Let's take a look. Create a table, work customer info, and we have the customer name, we have customer country, customer ID, birth date, and here's our from clause. From Orion DB, big customer dimension, and we tell it to use the database key to perform a lookup. And here's that smaller table, that Excel spreadsheet. So for each record, do a lookup based on the key where the customer IDs are equal. This is the data set option we can use for this table. And let's look at the results. Check it out. One repetition for every key value in the smaller table. In other words, to perform the lookup in that larger table for every key value in the smaller. So if you have a few values, not bad. But if you have a table that's almost the same size as the one you're looking up the match in, the database table, then this is going to not be as efficient. The smaller to the larger, the better. If you have that scenario, they're equal size, you can benchmark it. So in this case, this technique, we benchmark, and we get some good savings on CPU time. Look at the drop, also clock time, using the DBQ database key. Okay, we are ready to take a look at the demo. Let me share my screen and go back to my Enterprise Guide session. And we are going to take a look at SQM 04D09 program, this demonstration. In the comments, we have an example of the option SAS trace, which we've talked about. With these options, we'll have notes written to the log that will indicate if the database was used to do a query against one or more tables, and a reduction of some of the notes. Here's the %let, path equals S workshop, and we have a %include, which is used to reference a SAS program. This particular SAS program is livename.sas in the S workshop folder, and it has some live name statements that are setting up library references. You've seen this before. Then I have a live name statement setting up a library reference XL using the PC files engine to point to the XLSX workbook. And here comes the proc SQL. We are creating a table called work customer info as follows. I want the customer name, country, which I'm defining as customer country, customer type ID, the birth date. The data is coming from two data sources, this Orion DB big customer dimension table. And notice that we are making use of the DB key we talked about to reference the column customer ID, such that for the records in this Excel spreadsheet, we only need to look up the matching records for these smaller number of records in the spreadsheet within the bigger Oracle table. So don't read all of the data in the Oracle table, only look up those records that match, based on this key, those records in the small Excel spreadsheet. Again, here's the where condition indicating what's matching. Customer ID in the Excel spreadsheet equal to the customer ID and the big customer dimension table in Oracle. And then we clear the library reference for the Excel. And this is just a reminder how to turn off the SAS trace option. Let's run this. Here's the table. You see the 4 columns and the 8 rows. Let's check out our log notes. As I scroll down, you can see the path assignment of S workshop. Here's the %include livename.sas. And as a result, it set up all of these library references. Following that, we have the proc SQL step, which select these columns to create custom info from the big customer dimension table in the Excel spreadsheet, where the customer ID in the Excel spreadsheet is equal to the customer ID in the database table. And here's the notes pertaining to the 8 rows that you observed earlier. The last option It's the multi-data source option that can help performance for a cross-library join between a large database table and another table that's not located in the database. All right. So this can improve performance when joining a large database table with a small table. On the live name statement is where we put the option multi-data source to inform option in clause. So again, if you have a large table you're combining with a small table, it could be an Excel spreadsheet or SAS data set, this option can help performance. Without this option, this is what happens. With this option, notice, again, it's filtering for the bigger table, just those records that match what's in the smaller table. Only these rows are passed to SAS. Without the multi-data source option, we'll pull the data from the big customer DIM, extract the SAS, and then compare it to the big spenders table. With this option, the only records you get from that big table are those that match the records in that smaller table. Before extracting the SAS, makes it more efficient. You benchmark, here they look pretty close. As I said, table sizes make a big difference. That's why it's always good to benchmark. Just some key points. Joining data source live refs in different platforms is a cross-library reference type of cross-library operation. We have a small table and large database table. You might consider, I think it's a good option to copy that smaller table, Excel or SAS data set into the Oracle or whatever the database is you're using. I like the DB key option. The pursuit of join, if you understand how to build formats, can be useful. And we just took a look at the multi-data source option, which can improve performance. That's the end of chapter 4. Just a couple of points about chapter 5. Beyond what you observed in this class, there are a number of things that SAS offers support-wise. You might consider joining a user group. There's information online for technical support, professional services, education, more courses we offer. There are over 200 different courses, programming, statistical courses, intelligence courses. You can go to our link here. For certification, worldwide recognition of SAS certification in different areas, different subjects. Networking, with social media, interacting with SAS users and staff. Ordering books online, ebooks, publications, go to the publishing site. Beyond this course, there's a free version of SAS. It doesn't have all of the capabilities, but enough if you want to get some experience. And then SAS communities for sharing ideas, asking questions. Global forum, which you are aware of. There's online documentation for SQL, SQL, SAS Access, and database products. Beyond this course, we recommend the SAS Access to PC Files course, processing databases and PC file data. Programming 3, if you're looking to try to improve the efficiency of your programs. Those are some of the steps we recommend. And that is the conclusion of this course. I want to thank you very much for taking this course, and we hope to see you in the future.